welcome to Impactful Innovation with Commercis, the podcast series that tells the stories of the way that technology innovation is having a profound impact on our life, our work, and the world around us. I'm David McClelland, and in episode 2, we are lifting the lid on the mysterious world of the data center. If the network is the nervous system of our online world, then the data center is the digital brain that powers it. As always, we'll be joined by guests from around the globe to help us zoom in and zoom out on the topic. And also, joining us in the studio today is somebody who's spent, well, a good part of their lives inside data centers. Enno Wattenberg, Chief Technology and Innovation Officer at Commercis. Enno, thanks for joining us.
Thanks for having me.
So, data centers are... I started off my career in IT in data centers, but I want to hear about your first experience in a machine room.
Well, my first experience in a machine room was actually in a TV station.
Okay.
Like 25 years ago. And I wouldn't even call it a data center. It was more like an air-conditioned room with a lot of servers on a rack shelf. Not very nice, not very convenient, but that's my first experience with a so-called data center.
And that tells a story to me of the kind of journey that we've been on with regards to kind of on-premises, you know, whether it's a basement or a cupboard in some cases, moving to living in the cloud, where many organizations don't have a data center of their own at all. They're using, third-party hyperscalers data center services instead.
Yes, absolutely, because it doesn't make sense anymore. You can just basically buy compute power or put it into data centers, host it somewhere else, just depending on your needs, how large you have to have your connectivity, whatever. You can scale it up, can scale it down. You don't have to invest into the hardware. So data centers these days have massively changed. You don't need to invest into hardware, replace it every 3 years. You just go and have somebody else do it for you.
It's funny, I was thinking back to my first job, proper job, was in a data center back in the mid-90s, also working for a media organization. I was about 20 or so, and I was taken onto this machine room floor, told to wear a coat because it was very cold. There weren't not very many machines in there, so there was far more cooling than there was heating in there. And I was given a pile of tapes, DLT 4080 tapes, right. A big book of barcodes and a big tape library in front of me, and told to fill it up. It took me weeks, let me tell you. But yeah, that was quite an experience, and I think I've only just warmed up from my weeks inside the data center. But even that data center now, that was for a company that is now owned by a hyperscaler. So again, that tells the journey. Even those old data centers 20, 30 years ago are now being taken over by these big kind of conglomerates, consolidated data warehouses.
Yeah, that has definitely changed. And by the way, the temperature is higher now because we're trying to be economically friendly.
Well, hold that thought, because being economically, environmentally friendly is certainly something we're going to be talking about today and going forward in this series. Don't go anywhere, though, because it's time to hear from our first down-the-line guest today. And it's somebody we're going to hear from whose job it literally is to build and design data centers.
I'm Duncan Clubb. I am the Senior Partner for Data Centers, Edge and Cloud at Cambridge Management Consultants. I started my career as a software developer, then moved into IT infrastructure, and for the last 20 years or so, I've been working in and around data centers for all sorts of different organizations, big enterprises. I do a lot of work with investors, with data center operators, and also, public sector as well as private sector.
You've worked to build and design data centers for much of your career. How do you describe what a data center is to people who've maybe never been inside, and how do you summarize the role that they've grown to play in our digital societies today?
Fundamentally, they're just facilities designed to house computers, but they're done in such a way that allows for the systems that are hosted within them to stay up without interruption, regardless of what's going on in the outside world. So they tend to be very resilient. They tend to have levels of redundancy in their electrical systems that allow the servers and storage systems and networks within them to keep working regardless of what's going on externally. A lot of the infrastructure inside data centers is designed to keep the systems cool, or at least within certain temperature ranges, because most systems, and more so nowadays, more than ever, the systems we're using generate more and more heat. So a lot of effort is put into not just cooling systems, but doing it in an energy efficient way.
And these data centers, these vast warehouses filled with computers, as you might describe them, they've become more and more important to us as our usage of technology has changed. And particularly over the last 10, 15 or so years, we've gone from having applications and so on installed on our end user devices to more and more of the systems that we engage with daily living in these data centers.
Absolutely. The whole internet is inside data centers, hundreds and thousands of them. The amount of power that they consume is estimated to be between 3 and 4% of the total amount of energy consumed everywhere in the world. And data centers, our dirty little secret is that, our carbon footprint is bigger than the aircraft industry and the aviation industry. So they are huge. Most people, you may have driven past one, but you wouldn't know how to recognize one. Most data centers look like big warehouses, crinkly tin sheds. Others are in what look like office buildings. It used to be that data centers were built in office buildings themselves by big banks, big enterprises that used a lot of computer power. Nowadays, it's much more common for them to use co-location data centers, which are run by specialist outfits who just do data centers. And they also make extensive use of cloud services, which are run by what we call hyperscaler companies like Microsoft, Google, Amazon. So an awful lot of the compute behind the internet and behind all the things that we do and use is distributed around a huge number of very, very large data centers, which are now global.
Duncan, you mentioned energy consumption there. According to a recent McKinsey report, global demand for data center capacity will more than triple by 2030. Something like between 19 and 27% growth year on year between now, 2025, as you and I speak, and the end of the decade. As somebody involved in designing data centers, how are you seeing data centers change to accommodate the new ways in which companies and indeed consumers are using this technology?
Well, there's a number of things going on simultaneously. Because a lot of the growth is being driven by AI, and by the way, some people think the McKinsey prediction is a bit conservative. If that capacity was available now, it would be used now. They wouldn't wait for over the next 5 years. But one of the things that's changing is what we call energy density. So it's the amount of electricity that servers within data centers consume is going up enormously. So the simple way to view this is inside data centers, we put servers and equipment into racks, that sort of 7-foot tall cabinets with very standardized sort of mounting mechanisms. And you can get, between normally, depending on the size of the server, you'll get a handful up to maybe 40 different devices into a single cabinet. And most big data centers have hundreds, maybe thousands of these cabinets just arrayed in big lines, just for, sort of simple management. Now, what's happening is that what historically a rack would have consumed maybe 2 kilowatts of energy, that's the same amount of energy that a small fan heater would use, right? That number has gone up year by year in little sort of waves. it went from 2 kilowatts per rack to 8. Then the cloud services at companies like Amazon and Google moved to 16 to 20. Wow. And now what we're seeing with AI systems, which use a different type of processor, they're going from anything from 45 to 140 per rack. Now that's a phenomenal amount of electricity. So the engineering challenges in delivering that sort of amount of power, and also removing the heat that it generates, is a considerable challenge.
And a lot of this power consumption is driven by the CPUs, the GPUs. They are very thirsty, hungry, describe it how you will, but surely there has to be a process by which we can get more efficiency out of those processes without them consuming more and more energy.
Yeah, it's one of those things that the IT world in general has struggled with for a very long time. It's the more efficient you make something, the more it ends up getting used. So technically these systems are more efficient than they used to be, but the demand for them is much, much higher. There's a thing called Jevons paradox, which who was an economist in Victorian times, noted that the more efficient you make something, the more it gets used, which, simple corollaries of this are, you add an extra lane to a motorway, the motorway doesn't become less busy, it becomes more busy because there's more of it. So, it's just one of those, I think, inevitable rises in usage that we're seeing now. And as far as we can see, there won't be any barriers on that for some time to come, and it might slow down slightly once we hit a certain level of saturation. But every time we do this, something new comes along which drives demand even higher.
Let's talk about the communications part of the story here, because AI workloads require much higher throughput, much lower latency, which means significantly faster networks are necessary, both inside the data center, but also into the data center. How are data centers, how is the infrastructure around data centers adapting to support this increased network load?
Yeah, absolutely right. I mean, within the data center, it's quite easy to contain, but the really important stuff is in the sort of backbone of the internet that is installed throughout every country in the world, really. But the investment that's gone into improving the fiber networks pretty much everywhere over the last few years has actually really helped us be able to cater for this. So, I mean, at the moment, I think the networks are, they're fairly busy, but they're not saturated. But more growth in AI in particular, but just in data centers in general, will require us to install more and more fiber networks.
What are some of the innovations that you're seeing that are enabling greener data centers?
There's a few different areas where this is being done, but one of the biggest offenders in the past, if we forget about the IT kit itself, right, within data centers was the cooling system. So the cooling systems used to consume a huge amount of energy. And over the past probably 10, 15 years, we've become a lot better at producing cooling systems which are significantly more efficient. So it used to be the case that in a lot of data centers, for every kilowatt of power going to a computer, you'd be using a kilowatt to keep it at the right temperature. And now, there are systems which allow you to do that at significantly lower ratios. So you might only be using, a few percent of the energy that you're putting into the computer to cool it. Now, the next sort of real big step in this is going to be using liquid cooling. Again, it's one of those technologies that's been around for a long time, but it's sort of beginning to come into its own now. And the next generation of NVIDIA chips, a lot of those will be liquid cooled. So Liquid cooling is significantly more efficient than just about any other method because, well, two things. One, liquid is a much better medium for moving heat than air. On top of that, there's also the opportunity to reclaim the heat and use it for some form of beneficial purpose afterwards. So waste heat reclamations in the Nordics, where it started, I think, is being used to provide free hot water for municipalities. We're seeing a lot more of that happening, elsewhere in the world now, where the heat is being recognised as a valuable commodity, an asset.
Duncan Clubb, thank you very much indeed for joining us.
Very welcome. Thank you.
Thank you very much indeed, Duncan. And we'll be hearing from Duncan later on again in the series. Of course, this podcast isn't just about innovations taking place in Northern Europe, East Asia, or the West Coast of the US. And for our Zoom In story today, we're chatting with somebody responsible for designing digital infrastructures across some really challenging environments in Africa and the Middle East.
Nico Walters, Chief Innovation Officer at CMC Networks. We're a carrier providing connectivity services globally, but specifically focused on Africa and the Middle East. When we look at where we are right now, Africa's got about 185 plus data centers at the moment. We've got cloud providers, Azure, Microsoft, Google, Oracle, Ali and Huawei. So they're pushing up some of the data center space, although they predominantly focused on South Africa. And from a connectivity point of view, we've got 400 odd terabits of subsea cable capacity, coming into the continent, with 2 new systems being announced by Meta, for instance. That's going to up that substantially. And probably in excess of close to 1.5 million kilometers worth of terrestrial cable systems. So that's kind of where the footprint sits at the moment. The sad part is the majority of it sits in South Africa, which, as you can imagine, the continent being as large as it is, it fits pretty much every tier 1 country into it quite comfortably, makes it a bit more tricky from a let's say adoption point of view and use case point of view.
And then in terms of the infrastructure challenges that the region faces as well, what do you see there? And then what innovations do you start to see in response to those challenges?
Connectivity is a challenge in the sheer scale of it. I mean, even though we're reaching 1.5 million kilometers of terrestrial cable, let alone the subsea cable systems, that there's still a massive amount of the continent that's unconnected, just from a physical fiber point of view. Last year we had several subsea cable systems failures, from whether it's an underground or a subsea avalanche, as a friend of mine has said, that this destroys cables, cuts them in really hard to reach places, which takes significant amount of time to fix, collaboration from multiple countries, and it just causes an enormous amount of outages. And what we've had to do in the past, we're in a unique position that, as an aggregator working with lots of partners across the continent, we have the ability to innovate in terms of diversity, and taking away the reliance on set cable capacities or fiber routes, for instance. So whether we opt in GEO, MEO, or LEO capacity, in the satellite sphere, or we rely on some AI algorithms in our own core network to diversify network traffic. That's kind of the things that we've done personally to avoid and address these challenges, and innovation that we've done with Juniper, for instance, in making some of their protocols on the networking side happen in our context and in our core to address these challenges. The other point is data centers require massive amounts of power. You look at the US, for instance, we're talking 1,200 gigawatts worth of grid capacity, and you contrast that to Africa, and South Africa, for instance, sits at 60 gigawatts of power. So there's an enormous gap there. I was watching the Global AI Summit that they had in Africa recently, and that was in my opinion, great point that they reached that said we really need power infrastructure. So I feel the continent's rich in resources for sure, but on the flip side, we're sitting with let's say factors of 10 less power required for the kind of workload requirements that these AI systems, for instance, want to bring to the continent. So Africa's taken this, thought leadership concept and saying we want to be part and not be behind in the AI boom that's happening. But to say that, the requirements, for instance, just what Goldman Sachs was saying, at 165% increase in data center capacity required, in the next 2, 3, 4, 5 years, that has to come from somewhere. And I just don't see that we can build the kind of power infrastructure, whether it's nuclear, renewable resources, that quickly to match up with it. So those are the two challenges, just from a cloud data center point of view and connectivity point of view, that just pops in my head. And I think the other one that always pops in my head that we haven't really touched on in a lot of other conversations is talent, which is a significant barrier. When we talk about cloud infrastructure, we need not just sort of call it mathematicians and data scientists, for instance, to run AI systems, but we need mechanical engineers, civil, electrical. But I think talent is an opportunity Africa has. The population is very young. The percentage of people under the 25 mark that are in a position to upskill quickly and whatnot, to fill these positions, whether that's AI or engineering resources, is quite important. And I've seen quite a lot of governments like Rwanda, etc., starting to follow suit in this thinking to say we want to upskill the resources that we have, or the youth that we have, to make sure that we have the positions available to tackle that. So when these conversations around investment in cloud and content and things come up, I think that's one part that hasn't been touched on as much as it should be.
Enno Vattenberg is still here with us in the Impactful Innovation Studio. And Enno, it strikes me, listening to Duncan and to Nico, this pivotal role that data centers have really come to play in our digital world, almost by stealth one way or another. But just as crucial is it not, as well as the data centers themselves, it's the connectivity going in and out of them, because without that, customers, consumers, businesses just aren't going to be able to make any use of them.
It is about connectivity. I mean, you have to bring the data in and get the data out. If you don't have any connectivity, you can't process anything. Your AI doesn't work. Your photos can't be stored. So it's all about connectivity to the data centers. But the data centers are the brain where everything happens. So they store the data. They give you access to your photos, to your videos, to whatever you have somewhere in your pocket at one point, and you don't want to lose it. So where do you store it? In the old days, on a disk or somewhere else. These days, you just put it into the data center and have somebody else taking care of it.
Yeah. In my days, it was storing things on tape. Trust me, I know about those tape libraries by now. But you're right, we almost don't really think of the cost of storing stuff in data centers in the cloud. Goodness knows how many photos and videos me and my family have in cloud storage somewhere. I don't go through and delete those very often. But there is a cost to that, not only to me, because I pay for that cloud storage, but in terms of the energy usage, the energy footprint that my photos and videos take up.
It's not only that the internet doesn't forget anything, but as you rightly mentioned, the photos are there, the videos are there, you don't want to lose it. And you never delete anything, whether it's on your private PC, so it's the same in the data center. And it's not only that, I mean, you don't want to put it in one data center as an operator. So you put it in multiple data centers, just for redundancy, for backgrounds. Again, therefore you need connectivity, but also the storage capacity. And if you've downloaded some things on your phone or whatever, every time you get a new phone, you get more storage. So that's the same with data centers. They just simply grow and grow and grow. And not only that, more and more people want to have access to data centers, whether they know about the access center, more or less the cloud, they would call it. But in the end, the cloud is nothing more or less than a data center.
And as the saying goes, the cloud is somebody else's computer. And with that comes privacy and security challenges as well, right?
Yes, and that's one of the most challenging things in these days, because it's not only to protect the data center physically with fences, with security parameters or anything else, but there are so many actors outside that want to get access to your photos. Maybe because they just can, or use it against you for scamming you or other things. So it's becoming more and more important for protection, security, cybersecurity, defending attacks. Actors want to bring down services so that you don't have access to your photos anymore. So there's a lot of risk out there these days that data centers have to challenge.
And of course, there is that concept of putting all of your eggs in one basket, and having all of my stuff in a data center doesn't sound like a good idea. But that's where we actually start, when you start peeling away the layers of the cloud. It's not one data center, really, is it? Stuff is far more dispersed, far more distributed. Not only the backup copies, of course, but it's far more dispersed than we might initially think.
It's not only that you have one copy of your file in one data center and in another data center. Sometimes you even have parts of your file in different data centers. For example, if you upload a photo, it might be that the first 10 lines are in one data center, the second 10 lines are in a different data center, and so on and so on. So even if somebody gets access to one data center, he grabs the first 10 lines of your photos, but that's it, and he can get more. And if you think about security, if it's a photo, that is one thing, but if it's your banking data, if it's your social security number, if it's anything that's really a very important information and gives somebody a lot of information about yourself that he can use against you, this is the way how you protect it.
I'm thinking of this like the RAID arrays, the old disk arrays that I use. It's kind of like a non-parity RAID array that you grab one disk out of that array. You don't have really any usable data on it, just parts of files.
Yes, you can basically see it as a distributed file system and as a distributed disk.
And the data centers themselves, and we're going to be talking about edge in a future episode, but as we start to talk about the distribution of data centers, there are smaller kind of satellite ones as well as the big central ones, really, aren't there?
There is a big variety. So you have purpose-built data centers, especially for AI. They need a lot of power, they need a lot of cooling capacity, and then you have more disposed, distributed data centers, which are very close to the end device. So imagine you want to watch a movie or listen to music. You want to have it as close as possible to the end user, because you don't want to always move it through very still expensive links, because all the data centers needs to be connected with each other. So if you have the data as close as possible to the customer, you don't need to send it across links, and that's saving money still in these days. And the latency is much lower, so you don't need to buffer your video and all these kind of things. So there's a lot of logic and innovative technology behind these data centers and how they operate and how they feed customers.
Of course, it's all well and good talking about the my access to my family photos and my videos and so on, but it could also be to my bank balance. Big businesses rely on 6, 9, 7, however many nines availability of data centers in order to run their businesses that ultimately give us consumers access to, let's say, our money and so many more things that we do for work.
Well, I think if you imagine you're losing your photo, you can imagine how an enterprise would be losing data. Yeah. It's not only their data, probably, as you said, money is digital these days or whatever, but it's the customer's data that they might lose. Yeah. And that will not only give them a bad reputation, but that is a critical impact on their operations, and it's a critical impact for their customers. So it's not only important for you as a user of that, it's also very important for enterprises, governments even, that need to think about how they store data in the cloud, how they move it geographically, or where to store data and what's a safe place for them.
Yeah, and this all comes under the kind of resiliency umbrella, doesn't it?
It does, yeah. And resiliency can have many flavors. So as we've already talked about, different data centers can be different geographical locations, can be super protected, and can even be tape backups.
Can even be there's still a place for tape somewhere I do believe, but also again thinking with my business hat on, yes, availability, resiliency is one thing, but latency is another thing, isn't it? I don't only need my data to be there when I ask for it, but I need it to be quick quickly available quickly wherever I am in the world, and creating an environment, an infrastructure that really shrinks the time from me asking for something to me getting it. There's an awful lot of work that goes into that, not only at the data center layer, but also at the network layer.
It does. If you think of a stock exchange or whatever, where money is really down to the microseconds.
Yeah.
So that's where really latency comes into place, or where it's really crucial that you can do a lot of transactions in a very fast fashion.
Enno, great to chat to you today. Thank you so much for joining us here in the Impactful Innovation Studio. We'll leave it there for now. If there's one thing that we've learned, it's that data centers are, well, increasingly powerful and increasingly power hungry. So in our next episode, we'll investigate some innovations that can help power networks and data centers operate with more energy efficiency. And we'll look at the cutting edge of materials science for the successor to the silicon chip that could operate with just a fraction of the power of a traditional CPU or GPU. That's all coming up in episode 3 of Impactful Innovation with Commercis. But until then, from all of us here, bye-bye.